Welcome to this M1 walkthrough paper, May 2023. Okay, so in mechanics it's best always to draw a diagram where you can. So we have a particle A. So particle A of mass 4 kilograms and a particle B of mass 2 kilograms, and they move towards each other in opposite directions along the same straight line. So this one's moving this way, and then B is 2 kilograms and it's moving that way. Immediately before the collision, A is 2u and the speed of B is 3u. So that's my before. After the collision, the speed of B is 2u and the direction of motion of B is reversed by the collision. So we got A and we got B, and then after the collision that direction is reversed and it is at 2u. And this afterwards, we'll assume it's going in the same direction. As long as you're consistent with the directions, it will come up as a negative if A changed direction as well. Find in terms of u the speed of A immediately after the collision. So we've got to find our V in this case. So for this, I'm going to take this direction as positive. Okay, so before we've got, so mu, so that's 4 times 2u plus 2 times minus 3u, and that's the momentum before, is going to be equal to the momentum afterwards. So 4v plus 2 times 2u. So 8u minus 6u equals 4v plus 4u. So this is 2u, and then taking away the 4u we get minus 2u equals 4v. V equals minus a half u, or V equals minus a half u. So A changes direction and its new speed is a half u in the opposite direction. Okay, I've actually just answered B. State the direction of motion. So the direction of motion is reversed. Okay, that should be sufficient. In fact, in this case, if you said left, considering your diagram is showing, you know, the direction that you're going, then that would be, you know, should be acceptable as well. Part C is the impulse, and that is the change in momentum, so like mv minus mu. So its mass is 2 times 3u, not times 3u. Actually, let's start off with just a direction. I'll take impulse to the right. So the final one is 2 times 2u minus 2 times minus 3u, which which is 4u minus plus 6u, or 10u. And the units are Newton seconds. Okay, well, nice start, nice and easy, straightforward. Let's go on to question 2. Okay, so question 2 is about forces, and we've got particle P. So you can think of the forces pulling it or pushing it, however you wish to. So, you know, if I think of it as pulling, force F1 is going to be like this direction. And then force F2 is going to be in this direction. And then force F3 is going to be somewhere downwards. I don't know if it's down to the right or down to the left just yet, but somewhere that way. And then if I add up all these forces, then they should equal 0. So like F3 plus F2 plus F1 should equal 0. So F3 will equal 14i plus 3ci, and then plus, well, it should be minus really, but 7j minus 4cj, like so. So that's part A done. So part B now, C is 2, so F1 is equal to 6i plus 8j. So the resulting force is going to be F1 plus F2. So that is 14i plus 7j plus 6i plus 8j. Oh, sorry, it's a minus 14. So minus 14 plus 6 is minus 8i plus, and then 15j there, 7 plus 8j. So if we look back at my diagram, it's going up there somewhere, and then this is the horizontal, this is I, and this is the angle that we want to find. Okay, so I is across this way, and then we've got 8 to the left, 15 up, something like that. To the left, 15 up, and what we want is that angle theta there, the one that makes the angle with I. So how I would do this would be then find alpha. So tan alpha equals opposite over adjacent. So that's 15 over 8 shift tan. So alpha equals 61.93. And then theta, which is what we want to find, is 180 minus alpha. So minus 180 from that, and we get 118.07 degrees. It doesn't tell me what to round it to, so I can leave it like that, or 118 degrees to 3 significant figures. But as long as I've got the accurate one before it, and my choice of rounding is fine afterwards. So Cm is m, we have to find that, and acceleration is 8.5. So F equals ma. Now the force here is going to be with Pythagoras. So minus 8 squared plus 15 squared times m times 8.5. Yeah, so Pythagoras, because we're finding the size of the resultant line. You remember from the previous diagram we had that it was 8, that was 15, it was minus 8, and then that is the resultant there. So it's just using Pythagoras to calculate that size of that line. So 8 squared plus 15 squared square rooted is 17. Equals 8.5 m divided by 8.5, m equals 2 kilograms. Okay, so there's a constant acceleration question. So it's 1.5 meters above the buckets on a shelf, and it's just dropping down there. So it's 1.5 meters, u is 0, m is 0.2 g. Use similarly, find the time taken, so we've got to find t. And we know s is 1.5, and acceleration will be gravity. We don't need mass in this one. So we want u, t, s and a, so s equals ut plus a half at squared. So 1.5, u is 0, so that's just going to be 0 plus a half g t squared. Now in this case we're obviously taking down as our positive direction. So that's 3 over g I should say, t squared. So t equals, that's root 15 over 7, which is 0.55 to 2 decimal places, and that's seconds. Okay, so the second student suggests there's a particle falling at g but a constant resistance of r. Okay, and then s is still 1.5, t is 0.6, u is still 0. So this time we first find out what a is. So s equals ut plus half at squared. 1.5 equals 0 plus a half times A times 0.6 squared. So 0.18a equals 1.5. 1.5 divided by that. So A is 25 over 3, or 8.3 recurring. And then F equals MA. And the downward force is mg, so 0.2 g minus r. And that equals to 0.2 times A, which is 25 over 3. So R equals 22 over 75, or R equals, that's 0.293 to 3 significant figures. Okay, so at A, there is a PM G, and in terms of the tension, it's 4 times at C and at D, so 4T and T. And the mass of this is M, so mg. So resolving vertically, we get 4t plus t equals pmg plus mg. And then taking moments about A, the ones going anti-clockwise would be 4t times 0.6 plus t times, what's that, that's 0.2 at the end, so 1.8. And going in the opposite direction is mg times 1. And the PMG wouldn't count because we take a moment about A. So that's 2.4t plus 1.8t, which is 4.2t mg. And this one up here is 5t equals pmg plus mg. So t equals mg over 4.2, and substitute this into equation 1. So 5 times mg over 4.2 equals pmg plus mg. So we've got 25 over 21 mg equals pmg plus mg, minus 1, so that's 4 over 21 mg equals pmg, divide by m, divide by g, so p equals 4 over 21. Now, part B says that P was removed and Q was added in. It remains in equilibrium, but it's at the point of tilting. So, since Q's here, that's like one pivot point, but this point, so as this is pulling down, this one is about to tilt up here. So this T equals 0. So at this point, there's no tension in this rope or string, wherever it is. There's no tension in it. And this one could just be written as just a T or a P or a Q. Well, not P and Q because they're being used, but just another tension there. But we'll take moments about C, so we'll eliminate that. So we don't need this. Take a moment about C. So going anti-clockwise is QMG times 0.6, and then going clockwise is mg times, that's exactly in the middle, which is 0.4. So the m's will cancel, the g's will cancel, so 0.6q equals 0.4, so q equals 0.4 over 0.6, which is 2/3. And then part C, state of use the modelling assumption that the beam is uniform. If it's uniform, then its mass acts in the centre. So if uniform, then mass acts in the centre, or words to that kind of effect. Okay, so for this one, we've got to show the distance. So the distance is the area under the graph. So that's 30, that's V. And then this is T minus 30. And obviously it's a height of V there. So our distance is 30V over 2 plus T minus 30 times V. Now that's 15V plus TV minus 30V, which is TV minus 15V, or factorising out the V, we've got T minus 15. And that is what we had to show. Okay, you could have done it, I could have done one complete area, trapezium, that would have worked just as well. So the motorbike starts at T equals 10, so about by here, accelerates at the same acceleration as the car. Now it accelerates for 40 seconds. Yeah, so the car only accelerated for 30 seconds. So this is going to go above the line, like so. Now so above that line, and that time there will be another 20 seconds, so we'll be at 50 seconds. It then does a constant speed for 10 seconds. So to 60-second mark, and then it decelerates to be at V when T equals T, capital T. So it decelerates something like that. Obviously, if you went up a little bit less, it'd be crossing, and this would be a little bit shallower. It might not be this steep, it might be shallow, but it's something like that, where this is roughly this distance, this is parallel to this, okay, and they both end at T. Now on that's figure 2. Obviously you can draw it on this graph I had already used this graph, so I would have used this to redraw my sketch. Now for C, it's now show that the constant speed of the motorcycle is 4/3 v. So show that this height here is at 4/3 v. Now for this one, they're both at a constant acceleration, and that acceleration is exactly the same. So if I think of v equals u plus at, for both of them, for the car, v is, well, v, u is 0 plus a, and t is 30. So v equals 30 a, or a equals v over 30. And then for the motorcycle, v we don't know yet, so we'll just call that speed. 0 plus a times 40. So a is the speed divided by 40. And both of these accelerations are the same. So the speed of the bike divided by 40 is equal to v divided by 30. So the speed is v over 30 times 40. Or when you simplify it, it's 4/3 v. Now, the distance we've got for the car already, it's this, v brackets t minus 15. We've got to do the same for this one. Okay, so you can do it a few different ways. I'm going to split it up into, I suppose, 3 shapes. Yeah, 1, 2, 3. But I suppose there's more than one way of doing it. So this distance along the bottom here is 40. So it's half times 40 times, and it's 4/3 v, plus 10 times 4/3 v, plus, now this last shape is a trapezium, like that. So this distance is t minus 60. This distance is v, and this distance is 4/3 v. So it's a plus b, v plus 4/3 v over 2 times by h, which is that. So this is the distance. So 40, so 20 times 4/3, 80 over 3v, plus 40 over 3v, plus, so 4/3 plus 1 divided by 2 is 7/6v t minus 60. So this is equal to 40v plus 7/6v t minus 60. And this is the distance the motorbike travelled. Now what we need to do is equate them. So I'll just change the colour up. So we've got 40v plus 7/6v t minus 60 equals v t minus 15. So 40v plus 7/6vt minus, now 7/6 times 60 is 70. So minus 70V equals Vt minus 15V. So taking away 1 Vt will give us 16 Vt. And taking all of these to the other side, so 40 minus 70 is minus 30. Added to the other side becomes plus 30 minus 15, so becomes plus 15V. Cancel the V's, and T equals 15 times 6, which is 90. And that's the question done. Right, on to the next one. Okay, so friction less than or equal to a quarter R. Okay, where R is the normal reaction there. And then Pn we've got, this is P cos alpha, and this would be P sine alpha, where alpha is around 53 degrees. But if you look at it, tan alpha is 4/3, opposite over adjacent. So this has got to be 5. So cos alpha is 3/5, and sine alpha is 4/5. Okay, and we can use that then when we're working out these. So that cos alpha is 3/5, so that's 3/5 P, and sine alpha is 4/5, so that's 4/5 P. And this has weight W down there. So resolving vertically, we've got W equals to R minus P sine alpha, or R minus 4/5 P. And looking horizontally, I had to think how to spell it then. P cos alpha is equal to the friction, or the friction is greater than, or could be a little bit less. So like the friction maximum is greater than or equal to 3/5 P. So this is equal to R equals W plus 4/5 P, and F max is mu, which is a quarter R. So substituting this into here to eliminate R, we get 1/4 W plus 4/5 P. Because we've got to get it in terms of P and W, so we've got to eliminate the R's. So we go quarter, multiply by 4, isn't it? So W plus 4/5 P times by 4 is 12 over 5 P. Now 12 over 5 minus 4 over 5 is 8 over 5 P. Now we've got to get it P equals, so I should have taken it the other way around, but it doesn't matter. Therefore 5 over 8 W is greater than or equal to P, or P is less than or equal to 5 W over 8, which is what we wanted. So there's nothing much to this question. It's just know your formulae Okay, and substitute in. You didn't even need to know this bit, because when you put in the angle it would have given you these fractions anyway. Okay. Question 7. Right, car of mass. Oh. Yeah. 1200 G. Trailer of mass 600 G. Kind of straightforward. The driving force of the engine is 3000 newtons. Acceleration of 0.75. The non-gravitational resistant motion, so the car is 2r. I'll do this in red actually. 2r. And the trailer is r. And there's T tension in the tow bar. It's a light rod, so it doesn't have any weight to it. Now, what we're going to do is resolve parallel to slope. Okay, and we're going to take it as the car and the trailer as one. So the car and the trailer as one. Now, if I split this up, just redraw it for the sake of this. So I've got one here, normal reaction, 3000 newtons, 3, and that's going to be 1800 G. Now that's my alpha there. So going that way is 1800 G cos alpha, and going down the slope is 1800 G sine alpha. Okay, so I'm resolving parallel to the slope, so we're not taking any angles in, we're just doing these horizontal ones. Not horizontal, sorry, parallel to the slope, Now, I mustn't forget that it has an acceleration of a. So we're going parallel to the slope, but we're looking at F equals ma. So the force is the overall resulting one going up the slope. So that's 3000 minus 3r minus 1800 G sine alpha. The mass is 1800 and acceleration is 0.75. So we got 3000 minus 3r minus now 1800 times 9.8. So we got 1800 G times 1/12, haven't we? So I'll just redo this on the bottom. By 12, so it's 1470, and 1800 times 0.75 is 1350. So 3000 minus 1470 is 1530 minus 3r equals 1350. 1350. So 3r equals 180 divided by 3, r equals 60. Okay, so that's part A done there. Now part B, find the tension in the tow bar. Okay, so for this, let's pick the trailer. We could pick the car. We'll pick the trailer and we'll go, so it's F equals MA. Now the force is T, the tension, minus R minus 600G sine alpha. Okay, from resolving this force. 600G cos alpha is that way, sine alpha is that way. And that equals to 600 times 0.75. So 600 times 9.8 times 1/12 is 490. So I got T minus R minus 490. 600 times 0.75 is 450. Now R is 60, isn't it? So T minus 60 minus 490 equals 450. So 490 and 60 is 550 plus 450. So T equals 1000 newtons. Okay, so that's part B, and I get the same if I did the car. The car would have 3000 minus T, and it would be 1200 G, and so on. Now, when the car and the trailer are moving at a speed of 12 meters per second, the tow bar brakes. Given that the non-gravitational resistance to motion of the trailer remains unchanged, use the model to find the further distance moved by the trailer before it comes to rest. So first we need to find the acceleration, or more aptly the deceleration. Okay, so that is now the force, which is, there's no tension anymore because it was T minus R minus 600G sine alpha. But the T now is gone because it snapped, and that equals 600A. Okay, so when this snapped, this went, and this acceleration changed, it became a deceleration. So we got minus 60 minus and 600 times 9.8 divided by 12 is 490. Divided by 600, so minus 11 over 12. So that's my deceleration now, minus 11 over 12, or minus 0.916 recurring. Now it's going at constant acceleration, deceleration, yeah. So the speed it was going at, V, is 12, U is 0, A is minus 11 over 12, and we want the furthest, the distance, so we want S. So VU, A and S is V squared equals U squared plus 2AS. Sorry, V is 0, U is 12 there. So that's 0 equals 12 squared plus 2 times minus 11 over 12 times S. 144 minus 11 over 6S. 11 over 6S equals 144. S equals 864 over 11, which is 78.5 meters to 3 significant figures. So for part A, we're going to think from O, it's gone to 2 points, so minus 2I plus j, minus 2 plus j, and 923. Okay, and this is at 0 seconds, this is at 11 seconds, so that's the distance I want to travel. So 923 minus 21 is 1122. Okay, and then this distance divided by the time, so 11I plus 22j divided by 11 will give me my v. So it's I plus 2j. Sorry, that's v. Then R equals R naught plus vt. So R equals, now R naught is the starting place, so minus 2I plus j plus I plus 2j t. And that's all it is for the first one. Now, second robot is at point C. Time t equals 0, s leaves c, moves at a constant velocity of minus I minus j. At time t seconds, the position vector of s is s meters, right? Okay. So, looking at c, it's 25I plus 25j. Because it's relative from O, 50 by 50, so that's got to be in the middle, 25, 25. Okay, so that's S's starting position, 25I plus 25j. And then it's moving at a constant velocity of minus I minus j t. I could put the t in front here. I probably should put it in front, but there we have it. Now, part C, show that SR equals that. So, S to R, so I usually do R minus S, but you could do it the other way around. It's up to you. So R is minus 2 plus T I plus 1 plus 2 TJ minus 25 minus 1 TI plus 25 minus 1 TJ. So comparing the i's, minus 2 plus t minus 25 plus t. So minus 2 minus 25 is minus 27. T minus minus t is plus 2t I. And then we've got 1 minus 25 is minus 24. And then 2t minus minus t plus 3tj. And I could write them the other way round. And that's in meters. and that is what we were asked for down here. Now final part, part D, find the time when the distance between R and S is a minimum. So SR, the distance, is going to be Pythagoras. So that's 2t minus 27 squared plus 3t minus 24 squared, and then square rooted. So d, that distance, I'm going to make that squared so that I can get rid of the square root for now on the right hand side. So that is 4t squared 27 times 2 times 2 minus 108t plus 729 plus 9t squared minus 144t plus 576. So it's 13t squared, 108 and 744, minus 252t, 729 plus 576 plus 1305. And we want this to be the smallest possible value. Now for a minimum or a maximum value, it's basically differentiate and make equal to 0. This was that distance, but yeah, so differentiate it. So that's 26t minus 252 equals 0. 26t equals 252. T equals 252 over 26. 126 over 13, or 9.7 seconds to one decimal place there. The very end of this question, I think, is quite challenging. I can't remember if you would have done differentiation for finding minimums and maximums for rate of change in P1 and P2. I got a feeling, I can't remember where it comes now. Maybe it comes in P3. Anyway, I'm not sure if you have done that or not at this point in your course, but to differentiate and make it equal to 0, that turning point, that's going to give us our minimum or maximum value. Okay, in this case it's a minimum. Anyway, hope you enjoyed that. Don't know if you are enjoying it, if you're getting ready for your exams right now, but hopefully you found it useful, and if you did, please hit the like, subscribe if you haven't done so already, and catch you in one of my other videos.